Lesson 102, we are solving quadratic equations using the square root property. This is not a difficult lesson. It's actually quite simple. It's related to the bell work. We're talking about finding the square root or square roots of numbers. Square root or square roots of numbers. Using the square root property is what we're going to be doing today. This is another method for solving quadratic equations. What we're working toward is building the quadratic formula. Part of the quadratic formula comes from the square root property. All right, so the square root property says this: if, go back, too far back, if x squared is equal to b, or whatever the number is. This is a good old if-then statement. Then x is equal to what?
Square root of b.
Both square roots of b, plus or minus the square root of b. Now, I showed you guys this earlier in the year, but this is why a lot of people mistakenly think that the square root of 9 is plus or minus 3. The square root of 9 is not plus or minus 3. The square root of 9 is just 3. But the square root property says that the solution to x squared equals b is both square roots. Now, I can show you real quickly where this comes from. It comes from the fact that square roots have to be positive. Right? So if we were literally showing the steps, if we started with x squared equals b, and we literally take the square root of both sides, right? That's the process. What's the square root of x squared?
X.
It's not x, it's the absolute value of x, because the definition of this symbol is that the answer that comes out has to be positive, and so we force it to be positive. You force things to be positive by putting them in absolute value signs. And the principal square root of b, that's just the square root of b, whatever it is. Let's change this to a number to make it a little bit more meaningful to us. The principal square root of 9, just 3. But if the absolute value of x equals 3, what two values could we assign to x? X can be 3, or x can be negative 3. So the square root property, and using the properties of square roots, the definition of the principal square root leads us to absolute value here, which leads us ultimately to the positive and negative square root of the number. So the square root property says if x squared equals b, then x has to be the positive or negative square root of b, whatever that number is.
That's what I did on problem 10 about the juice, and I tried to solve it 4t squared.
Okay.
And then tried to square both sides, and I got some.
Yeah, it led you down the road because it's not that. Now, in the next unit that we're going to cover, deals with completing the square, taking something that's not a perfect square and turning it into a perfect square, so that you can use the square root property. But you can only use the square root property if you're dealing with something that is squared. If something squared equals a number, then that something has to be plus or minus the square root of that number. So let's look at a couple of examples that are pretty easy, foundational here. Guys, if y'all could pay attention up here and stop with whatever y'all are talking about, that'd be great. X squared equals 25. Okay? Did you hear me there? Did you hear me? Okay. X squared equals 25. Now, does this meet the conditions of the square root property?
Yes.
If x squared equals a number, does x squared equal a number here? Yes. Then we can invoke the square root property and say x has to be plus or minus the square root of 25, which is 5. All right? Now, we could confirm this by going back to what we did in lesson 91 and saying, okay, x squared minus 25 equals 0. X squared minus 25 would factor as what? X plus 5 times x minus 5. And we can see our two answers there by factoring also. Two zeros would be negative 5 and positive 5. All right? So let's have a look at another example here. If it meets the conditions of the square root property, then it's really, really nice. Does this meet the conditions of the square root property?
No.
Do we have x squared equals a number?
Yes.
Yes, we do.
Oh, yes, it is.
We do. X squared is equal to negative 16. So the square root property tells us that x equals plus or minus the square root of negative 16. Now some of you immediately started shaking your head when I put this problem on the board. Why did you do that?
Because it can't be plus 4 and plus 4.
Well, this does have a solution. It's just not what? It's not real. Okay? So this has, we could write no real solutions. Okay? It does have two complex solutions. The two complex solutions are plus or minus 4i, because I is the square root of negative 1. All right, so here's the two solutions. What does the fundamental theorem of algebra say? That a second degree polynomial has two solutions, or up to two solutions, in some field of numbers. And these two solutions just happen to be complex numbers. They're imaginary numbers. But we wouldn't say no solutions. We would say no real solutions. Buster, did you have a question?
I was going to ask you wanted us to put it as x equals plus or minus the square root of negative 16, no real solutions.
You could just write no real solutions from the outset of the problem. You wouldn't even have to write plus or minus the square root of negative 16. Or if you're savvy enough to know the complex answers, you can give me the complex answers. All right? X squared plus 3 equals 52. Does this meet the hypothesis of the square root property?
Yes.
If x squared equals a number. Do we have x squared equals a number here?
Yes.
We do?
Yes. X squared equals 49.
No, we don't have x squared equals a number. We can make it into that form, but the hypothesis of the square root property says if x squared equals a number. So, what does that tell me I always need to do? I need to get my squared part by itself so that I have x squared equals a number. And I can subtract 3 from both sides here. When I subtract 3 from both sides, I get x squared equals 49. And x squared equals 49 does meet the criteria of the square root property, and so I can take the square root of both sides, or use the square root property, and that tells me x equals plus or minus 7, right? Some of y'all are checking out on me about 4 minutes too early. Okay, don't do that. Stay with me. Next example. Does the next example meet the qualifications of the square root property? No. Could we solve this any other way?
Yes.
Yeah, you could factor out a 4, or you could factor it as a difference of squares just as it is, right? 2x plus 10, 2x minus 10, and then solve like that. But it's a lot easier to just use the square root property. If I add 100 to both sides, what do I get?
4x squared equals 100.
Divide both sides by 4. X squared equals 25. And that gives me x equals plus or minus the square root of 25, which is 5. All right? Good? Does this meet the qualifications of the square root property? It does, doesn't it? Do I have x squared equals a number? So then I know that my two solutions are x equals plus or minus what? Square root of 40. Is that a good number?
No.
It's an irrational number, but it's a number, right? It's a real number. We can't just move on because 40 is not a perfect square. The square root of 40 is one of those very important numbers that completes the number line. The number line is, real number line is irrational numbers and rational numbers. This is one of the irrational numbers. But I'm going to simplify it. What perfect square will divide into 40? 4, how many times? 2 times the square root of 10 is what we have, right? 4 goes into 40 10 times. The 4 gets to pass through the radical. The 10 is trapped inside. Okay? Couple more and we're done. 8x squared minus 124 equals 100.
No.
No what?
It doesn't, like, do the root.
It doesn't satisfy the hypothesis. Can we make it so?
Yes.
We can add 124 to both sides, right? And then divide by 8. Add 24 to both sides. What's 8 Does 8 divide into 124?
No, it does not. You
Yeah,
get
it's
like
15.5. You get
15.5. So we're not going to go there. What we're going to do is simplify it. So 8x squared equals 124. Divide both sides by 8. We get x squared equals 124 over 8 is going to be 4 goes into both of those, right? So that would be 31 over
31 over
2.
2.
Okay. So x equals plus or minus the square root of 31 over 2. We're going to leave it irrational. This is not a proper form, but we're not going to deal with that today. Okay. Malik covered a cube with exactly 864 square inches of self-sticking vinyl. A cube. How many faces are on a cube? 6 faces on a cube, right? Each of those faces, y'all listen, each of those faces has an area of s squared. So, the surface area of a cube is 6 times side squared. That's the formula that you need that's in play here. That is equal to 864. So we want to ultimately find the length of one of the sides of the cube. So we want to solve for s. Divide by 6, we get s squared equals
144.
144, which means s is equal to
Plus or minus 12.
only 12. Why is it only 12 in this scenario?
There's no
You can't have a negative side.
We can't have negative 12 inches, right? So kind of, y'all remember, the square root property comes into play, but we want it to be relevant to the problem. And in this case, negative answers aren't relevant. Can't have negative 12 inches. It makes no sense. All right?